Hello and welcome to a video series covering layered behavior systems inside of XNA. In this video series, we're going to take a look at how we can construct a behavior system that can be applied to actors inside of an XNA game. Now, in addition to coding behaviors as a separate system from the actors themselves, we're also going to give the ability to layer multiple behaviors onto a single actor. Now, throughout the extent of these videos, we're going to be covering several specific behaviors. We're going to be putting together, for example, a constant behavior. This will cause an actor to move in a specific direction. We will also be creating a gamepad behavior to allow controller input. We'll be creating a wanderer behavior that will allow an actor to wander on its own in random directions. We'll be creating a seek behavior that will allow one actor to follow another actor. And finally, we'll be creating an avoidance behavior, so that way one actor can avoid another actor when it is within a specific radius. Now, the idea is that as we progress behavior type by behavior type, we will be building towards an end example scene where we can begin constructing objects at a higher level, where we construct things behavior by behavior instead of line of code by line of code. The idea is that we put these behaviors together in a very general sense and then apply them in a more physical manner when we get inside of the scene itself. So as we put things together, we'll start out, again, very simply, but we'll be working towards an end scene where avoidance is used in multiple scenarios and everything is combined to give an AI demo where we have various actors with assigned roles, and they each play out their roles based on their assigned behaviors. Now, to give an example of what we're working towards, we have the final scene put together here, and we can run the scene to give an example of what we want to accomplish. Now, a brief description of the scene. You can see we have a series of triangles all being drawn to the screen. First off, we have this green triangle, and he is acting as the leader object. So all of the other objects that can move are all set to follow that one object. We have a series of gray-colored objects, which we're going to term drones. The idea is that each of the drones are assigned to follow the leader object. In addition to that, they're also assigned to avoid all obstacles, where obstacles are being drawn as the orange-yellowish arrow actors. Now, in addition to all of these types, we have one final type. You can see the red triangle is acting as an enemy object. He is trying to follow the leader. He's a good bit slower than the other objects, and all of the drone objects are treating him as an obstacle. They're all trying to avoid him. So with the enemy, we have an instance of a movable obstacle. So again, this is the demo scene that we'll be working towards creating with all of the various behavior classes. Now, one other thing to point out is the fact that each of the behaviors are themselves assembled as individual classes, or we have a base class defining the weighting and updating system, and then each actual implementation of a specific behavior is created as its own class. Now, in our scene, you'll see that we only have one behavior code file. This is because the examples we listed are relatively concise in code. Now, as you would progress into more advanced behaviors, you could certainly create individual behaviors as individual code files. The idea here is that the system is very extensible in the types of behaviors that can be created. One final thing I want to point out is the fact that the current behaviors are set to affect only the direction of actors. This was chosen because it keeps things simple in the demonstrated implementation, and it also keeps things unified. The idea that each behavior is really a direction affecting filter makes it very easy to implement and blend between behaviors. But I do want to point that out, the idea that all of the behavior you were seeing on screen was all based on affecting the direction of an actor. This could, of course, be extended to address things like speed and even direct positioning effects with an enhanced version of the behavior class. So with all these things that we've shown, this is what we're going to be accomplishing. So here, coming up in the next video, we'll begin with the actor, and we'll kick things off from there.